Hello, this is Rick here with MNPower. Been a little while since we've posted anything. What we're doing today, we're going to go over a quick installation guidelines, wire sizing, what to do, what not to do, what to watch out for, things of that sort. Also, just a quick run over of what we got here in the background. This is our system that runs the home. To my left and my right, this is our master all-in-one inverter, which is one of the earlier ones. This is a newer one. As you see, the only real difference is the name on the nameplate. That's it. Behind me is the Rosie and a Barcelona that we've done beta testing on. We used to run the whole house off of a stack of Rosies. It did it okay, but the all-in-one we started using, we could use a single one and run the whole place, but it's pretty well loaded up, so we added a second. We have 36 345 watt panels, Q cells on the roof. We have 16 more out on the lower porch roof, which 8 of those do an AC coupling. That's coming into this unit here and feeding to the all-in-ones. Hoy mile inverters out there on the roof. Our batteries, this is the MNPower test. This was the old test modules. Not quite as nice and up to date as these. This is the 5K battery. The new 5K battery as well has heat in it now. This is our 16K wall mount. Active top and bottom balancing, has heat in it as well. Another thing we want to jump into here right before we go into our wiring is don't cut corners. Get yourself a good meter. Don't do the Harbor Freight meter. Sorry, Harbor Freight. This is a cheap little meter from Lowe's, or no, actually this is Home Depot. But you see this one's that one's been with me a lot of years and it still works just fine. Not automatic. This is a Idea, I think this is a 400 amp true RMS clamp meter. Not my favorite. I had to pick this one up in a pinch a couple of years back, so I still have it. It's like new, like I said, not one of my favorites. My favorite is not here with me. It's missing in action at the moment. I think it's up in the truck. This is a really nice meter. This is a Fluke FS393. I think it's a 1500 volt 1000 amp meter. Has the hoop and everything with it, but you know, a little pricey. Best meter that I prefer is a Fluke T1000 or a Fluke T600. Good quality meter, less than $300. You want some good strippers, good wire strippers of some sort. Here's the page out of the manual. This is midnight code. 4-aught cables from our inverter to a bus bar. We need a bus bar that covers for if you're running a single inverter. This inverter will surge up to 400 amps for 1 second. You need a bus bar that will supply that or allow that to pass through. 2 inverters, you double that. This is a 600 amp bus bar, picked up off Amazon. That's a set of them, positive and negative. Have a nice cover, nice lugs, nice big heavy red copper bar. Very, very nice setup, fairly inexpensive. So what you would do from the inverter, 4-aught, down to your bus bar, then off to each of your batteries. If you're running the 5 kilowatt battery, then you can use number 2 cable. This is a number 2 copper. It just has a lug crimped on the end of it there, but this is just a scrap piece of number 2. This is 2 AWG copper, battery cable, welding lead, whatever. And you would run those individually from each battery to your bus or to your combiner, or you can stack. You can use 2-aught cable. This would be 2-aught cable here, and you could use 2-aught, and you could put jumpers between battery to battery up to a stack of 4, and then go 4-aught to your bus bar or 4-aught onto your inverter. But once you exceed 4, you'd need to go up to 4-aught copper. Then if you're coming off of the wall mount batteries, you run 2-aught. That's 2-aught, 2/0. You'd run 2-aught from each 16K battery to your bus, and then 4-aught onto your combiner. By all means, if you want to use 3-aught or 4-aught, more is always better. Less resistance with copper. Okay, enough with the battery cables. PV cable is spec 8. Most cases, number 10 PV is going to be fine. Then our transmission lines, AC in, AC out. We need to run number 2. This is number 2 THHN. This roll of red here is number 2 THHN. Then for your neutral, you can run the same size, or you can drop a size. This is what I run for my neutral. Then grounding says 8 to 10. I typically wouldn't run smaller than an 8. I always, pretty much across the board, I run number 6. That's number 6 stranded right there. And this number 6 wire needs to go through this ground toroid 2 times and then go into the bus bar inside the inverter. We'll cover toroids in a few minutes. I do not have a set of CTs lying here. I've sent out the extra ones that I've had. If you are tying to the grid, either metering, cell back, or if you're just net metering, or if you're just using the grid as a backup, you got to use these CT meters. This is the only form of communication that inverter has to communicate and read what's coming to and from the grid accurately. It's L1. L1 is always going to be your red cable if it's color coded, or should be. Should be on the right hand side. L2 is going to be a black number 2 cable. These CTs are marked. It's a faint marking, but they are marked. On one side says L1, L2. They have an arrow on one side of them pointing in the flow direction. They also generally have an arrow on the inside the cap showing the direction of flow. You always want to put this arrow pointing towards the inverter, away from the grid. That's important. If you reverse them, it's going to do exact opposite of what it's supposed to be doing. If you swap L1 for L2, L2 for L1, it's going to do all kinds of strange stuff. You're going to be calling. And that's one of the first things we go to check. When numbers are not matching and the machine's not doing what it's supposed to, it's sending power where it's not supposed to, we're going to the CTs. This is 4-aught. And, well, that's just another piece of 4-aught. And if you're using our 16K battery, a single 16K battery, that's 2-aught. And then on our 5K battery, for single battery, if you're going to run cables like the rat's nest behind me, That is 2AWG number 2. So that's going to be the cable that you'd run individual to some type of bus bar, you know, whether it be one of these or something else, for a bus bar. From our 16K battery, you need to run a single 2-aught from each battery to a combiner of some sort, a combiner or a bus bar. If you're only running 2 16K batteries, you can run a 2-aught from each battery, and you can invert them as you tie onto the inverter's bus, and they'll go right on there. It clears. But otherwise, we recommend a bus bar, a single inverter of at least 400 amps, twin inverter at least 800 amps, triple 1200, and so on. Then on the smaller batteries, again, we use number 2 to a bus, and then you go 4-aught from your bus, always 4-aught from your bus to your inverters. I think that about covers DC, and that is spec right here in the manual, and you'll have a manual if you got an all-in-one or you acquire one, you will have that, and then it's specified. We're going to go into the AC cable now. Okay, now on to our AC transmission lines. For our AC, we spec in the manual of number 2. Now, for a ground, we spec 8 to 10. I use number 6. And number 6 will fit the ferrite, and I'll show you shortly. This is going to be number 6 that I use for a ground. You can use a bare copper going to your earth ground. This is a number 4 neutral. Usually a lot of times I drop a wire size for neutral. This is your number 2, and I try to get red and black. If not, if you can't, just mark it very well at both ends and a few places on its way. That red is your number 2 or L2. We want to always specify L1, L2. L2 is red, right hand side generally. Okay, I'm gonna go into a couple other little details. Stripping wire. When you take, and I've got a bad habit of this, but I've practiced it. I slightly cut in, and I score my wire. I pull it out, and that's pretty clean. I nicked it a little bit. But what happens if you score a wire like that? I guess you can see that scoring in the video. That creates resistance, builds up heat right there. So we want to be careful not to do that. The ideal way is to get yourself a good stripper, but probably the cleanest way is to cut this way. If you score the wire as you're cutting down like this, it does not create resistance and heat, as long as the scar is going with the strands. If it's going across the strands, as the energy travels the coating or the perimeter of the copper strands, when it hits that bump, it creates resistance and builds heat. Can cause a failure. Also weakens the copper. Okay, this is our shielded 4-conductor. Has a nice ground, and you can take that full wrapper and you can just kind of twist those up together. Cut the aluminum off if you want. I usually just twist it right up together, and then I ground that to my ground bar. Use a good set of strippers. This is 22 gauge, so you want something small. use this. Well, that didn't, my stripper's nastied up there. Nothing ever works right when you need it to. So then you want to twist that up. It's really best to use ferrules on these things, and you'll see why in a minute. Okay, this is a little 22 gauge ferrule. I'll put that on there. That's okay if it's a little long. Just slide it all the way in. Nice tight crimp. Then what I do if I have excess on there is I just take and just snip that little bit off, nice and clean. And then you would do all four of these the same way. You want to make sure your wires are all as close as possible, same length. You'll want to strip this back. These wires will be a little shorter than this ground wire because the ground wire's got to go on up and around to your connector, to your ground bus. So you want to make sure that is a couple inches longer. And you can always cut it to fit. Okay, now we're going to move on into the wiring process. Here we are, a couple more items before we go look at the machine. This is all of our dry contacts, our stacking communication, RSD. Pins 1 and 2 are taken here, but 3 and 4 if you have an RSD. By all means, if you're running any kind of an RSD or optimizers or anything, test them when you hook them up. Make sure everything is functioning properly because it will not work right. Pins 1 and 2 is generator, dry contact. These do not take voltage. This is going to be our pin out. This is what we're going to look at right now. Is our communication parallel connectors. That's this section here, and as well RSD. This is for stacking, just color code. And then dip switches, you have, if you run the 3 stack, you go up, down, up. If you run the 2 stack, it's just up, up. Single, just up. All right, here we are. We're gonna go inside our unit. I've done got the screws out of this and the ground wire off. We'll go through. This is our AC, 100 amp AC in, AC out, 50 amp AC coupling, which we're using. 30 amp smart load, got a 60 amp smart load generator. Then we have 4 total of 20 and 3 15 amp just outputs. These are not smart loads, they just supply power straight off of the AC out. Okay, this is number 6, double wound around my ferrite. Then this is our ferrite for the 4-aught on the 4-aught battery cables here. If you run 2 sets of 2-aught, it's really tight getting it in here. Some 2-aught cable will not go 2 sets in there, so you need to consider that before you run 2 sets. It'd be best to get a bus bar. But these ferrites have got to be located in the case. These catch frequency. They filter noise. So it's very important that these be in here. You can even get the little clip-ons and clip them onto PV and different things as well. I've had some of your AHF guys, your radio operators, I've had a couple of those guys do some of the clip-ons and really quieten their radios down substantially, if not completely. And as well our 300 amp DC battery breaker. Now, as we go in here, these are a number 2 Phillips or like a medium flat blade screwdriver. make sure you got you a good screwdriver bit for these. Don't strip them out. Not necessary. I'm using ferrules on these. Ferrules are not totally necessary. It is necessary to use copper. Nothing but copper in it. You're on a DIN rail. If you need, you can pop these tabs, and that breaker will lift. It'll lift right out of there. Just like that. If you need to get to it that way. Just want to watch, not be pulling on these wires here. You got to be very careful with that. Really not that great of an idea to take them out unless you have to for some reason. And then they clip back in. Just like that. All these breakers are that way. But again, if you do remove them, you got to be very cautious with these other connections. Use torque specs on everything. Now, our pinout on our communication. This block unplugs. This is on the newer style inverter that they unplug. On the earlier ones, they don't. These are my two tools of choice to do this job here. If I've got them plugged in, I'm gonna do this plugged in back here the hard way, so you can see the worst case. It's easy to get it out here, and if I've got the block out, I use very carefully this pair of dikes with a nice sharp edge. I can clip right on the edge of that, and I can open all 4 clips at the same time. But again, these are not, you don't want to abuse them. This little flat blade, just a little bit of pressure. It doesn't take much. Push it right in, and it pulls right out. Set it back up there. Push the pin in, goes right back in place. There it is. All these other pinouts, just does not take much pressure at all. With ferrules, they just push in. We'll zoom in here, we can see. This is your dry contact for the generator port. Does not take very much pressure at all to make those function. And it's kind of an upward, a little bit of an upward angle. And then this is all of your PV connection points. They're just clip in. These are already installed. We're not going to go through that, but we'll strip you back about 1 inch of copper and get it up in there and clip it in. This is number 6 copper. This green ground. And see, that's 2 winds through the ferrite. And then our battery cable ferrite here, toroid. Those have to be inside the inverter case here, not down in the tray. We want them up in here. Good. Okay. Another thing that I want to emphasize, we find a lot of, especially in homesteads and where other electrical boxes where there's been additions and then you add on sub panels and things of that sort. When a electrical supply comes into a structure, as soon as it comes in, there's a neutral ground bond. You only have one. And we find that in a lot of cases, there's other boxes throughout the property that's being powered by the same power supply, that there's multiple neutral ground bonds. And with grid power, it doesn't really affect it. It is, but you never know it, because you're looping is what you're doing. You can actually burn a house down. With more than one neutral ground bond, it'll cause shutdowns with the unit. And they'll be random. It's according to how strong it is and where it's at. We've had shutdowns that have gone on for quite a period of time, and we knew it wasn't our machine. And then we go out to the location and we find a J box on the other side of the basement that has a receptacle in it. And when they put the cover on, they pinched the neutral wire. The box was grounded, so that created a neutral ground bond. So that made two neutral ground bonds, and just every week or two, the machine would turn off. And then after you fix that, the problem goes away. These machines are very sensitive to neutral ground bonds, and it's for a reason. It's a safety. That's even electrical code, only one bond in a system. So watch for those kind of things. You can even you can purchase, I wish I have one somewhere, but you can purchase a little plug to test your receptacles with in your house to make sure that they're not reversed. If you don't have one, I would suggest purchasing one and making sure that all of your household plugs, because when those are wired wrong, they're okay until you plug something into it and turn it on. And then when you turn it on, you create the ground loop. So these are just other little things to watch out for in installation. In the event where we have multiple neutral ground bonds, more than one in a system, when you have that, you create a looping effect. And if you ever have an appliance, something shorts out on that circuit, it likely will not trip that breaker, and it will just continue to circle loop power at a rapid rate until it overheats the wiring and either burns the wiring out or catches fire and burns the home. And that is why our inverter is very sensitive to multiple neutral ground bonds. That's all we have for today. Thank you for watching. I hope this is helpful information. Let us know. Drop a line. MidnightPower.com. Support at MidnightPower.com. Have a great day.